Alright, so this is lesson 1-4, linear functions and models. First slide here says a rail on a railroad track expands with heat and contracts with cold. Since its length depends on the temperature, we say that the length is a function of temperature. If you think about that, like the roads, why they crack in the winter or in the summer or whenever they do crack, is same thing. Heat makes them expand, cold makes them contract. So when they're constantly going back and forth like that, that's why the cracks end up getting in the roads. So we have a function here. It says L equals 0.0001 t plus 10. And the 10 stands for the original width of the rails. So if they gave me a function and they gave me some t values in Celsius, my degrees, how do they get this 10? What I would do here is I would take my calculator out and I would plug in to my calculator .0001 times, and then put in a 0, and then a plus 10, and then that's how they get 10. So what would you get if you filled out the rest of those? So now put in a 10, check your answer, put in a 20, put in a 30, put in a 40, and you guys can put them in while I'm putting them in right now. How do we bring back our original equation? The shortcut was always second, enter. And that brings back my original equation. Now I can plug in a 10, and if I don't have enough room, I can go second, and then the insert button, which is right here by the delete button, DEL. So second, insert, and then you just type in the number. So now I'm going to plug in a 10 and hit enter, and my rail width has got a little bit bigger. So this is a railroad again, so you got a railroad. Okay, the distance between here and here started at 10, and now the temperature is getting warmer. It's at 10.001. Okay, and if I go second, enter again, I can then change that to 20. And now it's 10.002. And then I can go second, enter. And then move it back over here, hit 30. 10.003. And second, enter, 40. 10.004. Sorry, 004. Okay, so I now plug in the numbers, and another direction that it'll tell me is says to graph the function. Okay, so if I was going to graph this, what would be my x-axis? Would the L or the T be my x-axis? And in this problem, we're going to pick T as my x, because that was my input value, and then my L, my length in meters, is going to be the y value. So, if I were to graph this, this is my temperature, and then this is my length. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I put my plot here. And so at 0, 10, my point would be here. And this, we can call that 10 degrees, 20 degrees, 30, and 40. And I can plot the points now. So 10.0001, which looks like right here. Okay, 20 degrees now would be 10.002, so about right here. At 30 it'd be 10.003, so right here. And at 40 it's 10.004. So if I look at my graph, it should be just barely increasing, which would make sense, right? If you have railroad tracks and it gets hot, you don't see the railroad tracks expand by feet, it's just barely expanding, and then when it gets cold it barely contracts. So this is a graph that has an increasing positive value for my slope. Okay. Here are other functions that you guys have dealt with. Now you guys have dealt with functions for who knows how long, since Algebra 1, okay, or probably even before that. Anything where you plug a value in and it spits a value out is a function, okay? And like on this one, this says f of x equals 3x minus 5, and f is a linear function of x, because x is what we use, but f is the function of x. Okay, we can write it f of x, L of t, g of s, h of t. It's just another way of writing the function. Okay? So, let's read this problem and maybe see if we can figure it out. It says, the senior class has paid $200 to rent a roller skating rink for a fundraising party. The tickets for the party are $5 each. Okay, and then part A, express the net income as a function of the number of tickets sold. Net income is the amount of money you're going to make altogether. Okay? With the cost taken out. So, what are the costs, or what things do I have to pay for in this problem, and what things are going to be making me money? So yes, in this problem, what I'm going to have to pay for is I'm going to have to pay $200 for the skating rink. If you're paying something, are you gaining or losing money? And I would be losing money, so I'm going to have to pay $200 to rent the rink. Okay? What things are going to make me money? Well, $5 for each person that shows up. So $5 for, we don't know how many people are going to show up, so I can put an X there. 5 times X would be my function. Okay, and then if I want here, I can say f of x is my function that I just got there. Okay? So now part B, graph the function, identify at what point the class begins to make a profit. So let's graph this. Now f of x equals, that's pretty close to equations that you guys know how to do. What was f of x always the same as that I said last year? And it's a y, so this is like y equals 5x minus 200. I think every single one of us knows how to graph this. So down, we'll say 50, 100, 150, 200. Okay, so the y-intercept is 200, and it's up 5 over 1. Up 5 over 1, up 5 over 1. Okay? So the question is, could I also go, instead of up 5 over 1, could I go up 50 over 10? Is that the same as 5 over 1? Yep. So up 50 over 10. So we'll call this 10. Up 50 over 10. Up 50 over 10. And then up 50 over 10. Okay, and then up 50 over 10. Okay, now you have your line. Okay, the question says identify at what point the class begins to make a profit. So when are they going to start making money? Okay, at 0 tickets they're down $200. At 10 tickets they're still down, these should be negative on those, money. Where are they going to eventually start crossing over and getting into the positive values? Okay, and that answer would be right here at 40. 40 is called the break-even point. Okay, what else is 40 called mathematically? It's called the what of the function? The 0 of the function. Okay, so this is called the 0 of the function. And that's where we're going to break even and we're going to start making money. Any more than 40 students showing up to this skating party, we're going to get money out of it. And we'll make money for the senior class. Okay? So what would the domain be in this function? Domain of my x values that work, or the set of inputs. So where did I start on my x-axis? My domain, I would have started at x equaling 0. But then which direction would I go from there, right or left? And I would have went right. So that means x has to be, which way is right, or greater or less? And it would be greater. Could also be equal to 0. So x can be greater than 0. What's my range? So where's my lowest amount of money that I would lose, and where's my highest? My lowest for my, again, range is the y values. So my y value's lowest point would be down here, and the highest we don't know. We can have as much money as we want depending on how much show up. So y can be greater than or equal to 200. Actually we'll go negative 200 because we're losing 200 down there. So that problem would be a loss of 200 or anything bigger than that can be my range. And that's $200. Questions on that? Alright. Suppose it costs 50 cents. Here's another problem just like that one, similar. Suppose it costs 50 cents for the first minute of a long distance telephone call and 20 cents for each additional minute thereafter. How would I write the amount of money I'm going to make on that? So between 0 minutes and 1 minute, how much money would I have to spend to start? So it's 50 cents for the first minute and 20 cents. So first minute would be anywhere in the first minute. So automatically it'd be 50 cents. Okay, let's talk about in between minute 1 and minute 2. So now I'm adding another minute. Well, every additional minute is now 20 cents. So it'd be 50 cents the starting point plus I'm going to add 20 cents. And then between minute 2 and 3, I'm going to add another 20 cents, which is actually 20 cents. And I still have to pay the original 50 cents. On this problem back here, I actually just had 20 cents. And guess how many 20 cents I technically have right here? I have 0 20-cent additional minutes. And then here, if I started between here and here and had 0, I had 1, I had 2. Between here and here, how many extra 20 cents would I have to give or pay? I have to pay 3 of them. Okay? You can see a pattern right here. There's a function that I could write from this. Okay? And it actually has an equation if I wanted to find it. Okay? Now, if we think about this, I'll come back to the function part. Okay, this right here, this example, is called a step function, and that's this red part over here because if you think about it, it's 50 cents to start for the first minute. Okay, once it hits the minute mark, it's still 50 cents, but then when it's a minute and 1 second, it jumps to the next minute. So now it jumps like a step, okay, and then it's going to come across for another minute, and then it's jumped 20 cents, okay, and then it jumps 20 cents again for another minute, it jumps 20 cents again for another minute. So this creates steps, and this is called a step function. We did a little bit of step functions last year in Algebra 2. Okay? And this right here would be a linear function. Now if we look at my first equation, if you see this pattern, what's changing here? So if you see here, do you notice how these guys are the ones that are changing? Anything that changes in algebra, we're going to use a variable, so we'll call it x. Ooh, that should be 20. Okay? And would this equation be the same equation that I have down here in blue? 20 cents. Now, this problem I didn't use the decimals, but now I did, so we're good. Okay, if they use whole numbers, we could use decimals, depending on what you use to label your graph properly. Okay, and notice, does this step function and this line match up properly? And it is the same equation, so the line is kind of like an estimate of what the step function would be. So the line actually doesn't give you the exact value, or this function, the linear function, doesn't give you the exact value, but it'll give you an answer that probably would be close if you were to estimate. Okay? Let's find, so it says if f of x, here's another type of function problem that you'll have today. If f of x equals 5x minus 10, find f of 3 and f of negative 3. What does that mean we're going to do? And whenever they give me f of a number, all I'm doing is I'm taking that number and plugging it into my calculator, where the x is. So you're inputting it where your x is. So it can be 5 and then parenthesis 3 minus 10. Just plug it in. You guys did that a lot last year. Get a 5. And if you want to do the f of negative 3, you can plug that in and get a negative 3. I should just hit second insert, but, and we get negative 25. Okay, so those are simple. So this gives me a 5 here. F of 5 by plugging it in. And then this here would be f of -3 equals -25. Okay, find the zero of the function. We did that a ton last year. If you're trying to find the zero of the function, what do I do to my equation? I set it equal to 0. And then solve. So how do I solve this algebra problem? I add the 10 over, and then I get 5x equals 10, and then I divide by 5, and I get x equaling 2. Okay, so 2 is the zero of the function. Alright, another question here says graph the function. So, again, you guys know how to graph. So what is f of x the same as? A y, so it's like y equals 5x minus 10. Okay, so you'll graph a little bit today probably. So what's my y-intercept? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -10, and what is my slope? Rise over run. So up 5, over 1, up 5, over 1, up 5, over 1. Okay? Notice, is this 2 the zero of the function that I found right there? And it was. Question here says, where does the graph of f intersect the what axis? Vertical axis. So which way is vertical, up and down? You're vertical, or left and right? And vertical axis is the up and down. So where does it cross the vertical axis? -10. Where does it cross the horizontal axis? That'd be the left to right. And that would cross at 2. This would actually be y equals -10, and this would be at x equals 2. Okay, and where does the zero of f appear on the graph? Well, we already determined that. It appears at x equals 2. And again, that's the crossing point on the x-axis, and that is called the zero of the function. Okay, and last thing we need to know today, using the equations, s equals 2t or s plus t equals 8. Express t as a function of s. So we're expressing t, which means we want to get t by itself, and the function is going to use the letter s in it. So we're going to get t by itself when it says this. So again, just minus the s using algebra. And the order here doesn't matter because you're not technically doing a line yet. Now I can divide everything by 2. So t equals, and actually if you want, you could just probably do 1 division by 2 with the whole thing if you want. So 8 minus s all over 2. Okay, you can leave it like that, or you could divide each one separately and it'd be t equals 4 minus half s. So either one of those would work. Questions? All right, good luck.